Hello, this is the MEC 2302 Dynamics Assignment 7. Let's get started. So my name is David Ackerman, student number 220310629, and let's get started. So these are the givens by the problem where we're given the wheel mass, the radius, that's KB, the initial angular velocity, the coefficient of a kinetic friction, the AB length, the BC length, and the wheel radius. These are the diagrams. This is the MAD diagram. This is the wheel diagram. And this is the ABC diagram triangle, where the X is the distance between A and C, which I just called X, and we're using Pythagorean theorem, and we get 0.5. We're trying to find the horizontal force at AX, the horizontal force AY, and the time it takes for the wheel to stop. This is the whole analysis. So part A is at first we're focusing on the so resolving the forces on the horizontal axis, where we take the forces of Fx, which is ma, F equals ma, the summation of forces. This is the force of friction of C, which is minus the force of AB cos theta. Here, we don't really need to know theta because we're given all the sides, and since SOHCAHTOA is a certain ratio, we just substitute cos for 0.4 over 0.5 and substitute the force of friction with mu Fm, which is mu and the normal force. Here we then simplify, we substitute all values and simplify, and then here we're solving for FA. So we're putting Fn to one side and FAB to one side. So this is equation one. Forces on the vertical axis, now yet again, Fy equals ma, but the acceleration is in the y. And here yet again, uh, acceleration is zero because mass can obviously never be zero. It cannot be zero in this scenario. We have mg, which is negative force of gravity, force of normal c, and then FAB sine theta because this is in the sine direction. This is in the y direction, as per the triangle. And here we're doing again then the ratio because of the triangle. 0 point sine is just a ratio, and that we're making the 0.3 over 0.5. Here we're simplifying everything, and we're putting mg to the other side, which becomes positive, and simplifying and solving all the problems. And this gets to equation two, where we still have two unknowns. And this is equation three, which is the moment of inertia, which is the moment right there, plus right here, and the force of friction times radius, and mkb, which is the gyroscope radius, as the kb equals 0.15, and um, right here we substitute all that in for mass 25, 0.15 squared, and here we're simplifying it, and this is as further as we can get. So now we're going to start solving all that. So substituting equation one, which is into equation two, and solve for force of normal at C. Here this is the actual equation that we're equation two, and we're substituting right here into equation one. And here we have all force of normals. We add them up, divide 1.375 into the other side. We get force of normal equals uh, 178.36 newtons. We plug that back into the equation one, and we solve for FAB, and we find out that FAB equals 111.48 newtons. Then again, we're substituting force of normal c into equation three, and then solving for angular acceleration. We're plugging it in, solving for angular acceleration. We get angular acceleration, dividing it by both sides, simplifying for it. We get 31.71 radians per second. So right here, we're using the kinematic equations of motion. This is the equation of linear momentum or linear motion, and this is for our angular motion. Basically the same thing, but they change variables. They're the same principle. So here we're plugging in all the values that we know, and we find out that t equals 1.26 for the time it comes to stop, because WT is for the time that it's at zero, -40 is the time that we currently have, and angular acceleration is what we solve for. So it would take 1.26 seconds for the wheel to come to a full stop with the given conditions. Now we're solving for AX and AY. This is the diagram that we're given, like resolving out the forces. Um, so FAB RxN is equal to FAB, which is 111.48, and um, we're just this is just a simplification for AX, and we're plugging in FAB, and then cosine again is just a we don't have to know the theta value, but we can just substitute it because it's a ratio, and we get that AX equals 89.18. Same thing for the AY, plug in all the known values. Sine is just a ratio, which is 0.6, and we get that AY equals 66.89 newtons. So therefore, the components of pin A on AB equals the horizontal component is 89.18, and the vertical component is 66.89 newtons, respectively. So part B is in order to improve the wheelchairs designed for the elderly, stability can be enhanced by widening the wheelbase, lowering the center of gravity, and adding an anti-tape features in case that they fall over. Comfort can be improved with shock-absorbing materials, ergonomic seating, and adjusting positions because of old age. They need to have a constant motion on the back and provide stability. For better maneuverability, using high grip tires so they don't have to reach all the way to the ground, so it's more comfortable. Lightweight material, so not too much force needs to be applied in order to provide motion, and efficient braking systems in order they need if they need to brake quickly and effectively would be ideal and key. Durability can be increased with a low friction bearings and weather-resistant components, such as if they're using it in a very hot environment or very cold, rainy, dry, the brakes would uh, be ideally functioning and not give in. And lastly, accessibility features like an easy self propulsion, motorized comparability, and adjusting armrests and footrests can make the wheel more comfortable and user-friendly for the ones that would require such comforts, such adjustment features on the wheelchair. This has been my assignment. Thank you so much for listening.